The definition of a logarithm is always base b with a particular growth factor b. And so the key is the value is equal to b raised to some power. Then the logarithm way to say that is over here, the logarithm base b of the value is equal to the power. So the point is, if you want to know what the exponent you need, the number of growth factors you need to get to a certain value, that's the logarithm. The logarithm finds the power, the exponent that you need to get to the value. So for instance, the log base 10, if we're talking base 10, growth factor 10, how many times do you have to multiply by 10 to get to 1,000? Over here, well, that's 3, since 10 to the third is 1,000. The log of base 10 of 1,000,000 is 6, because 10 to the 6th is 1,000,000. So how many factors of 10 do you need to get to the value? Let's look at another base with a base 2, where the value equals 2 to a power. In that case, the log base 2 of the value would be equal to that power, that exponent that you need. So for an example, 2 to what power is 1,000,000? Well, by zooming and checking, you can do 2 to the 19.93 is 1,000,000. 2 to the 20th is just over 1,000,000, and it's a little bit too big. So in that case, log base 2 of 1,000,000 would be that exponent, that power, which would be 19.93. So here we're going to work with base 10 in a lot of examples, and I'm going to try and show you how to think about logarithms so that you can solve these problems. So this first problem, 10 to the t equals 10,000. Well, we know 10,000 is a nice number, and we know 10 to the t, 10,000, we can write it as 10 to the fourth, so t equals 4. But the logarithm way to solve that is to think about the logarithm of 10,000 is the power in the exponent here, right? So if you, on your calculator, if you can take the logarithm of 10,000, you're going to get the exponent that you need. So in some cases, if it's a power of 10, that's easy to do. But what if it's 10 to the x is 137? Well, we know x is going to be between 2 and 3 because 10 squared is 100, which is too small, and 10 to the third is 1,000, which is too big. So it's going to be between 2 and 3. And how do we find out exactly what it is? Well, our calculator tells us. And what we can know is, and our calculator tells us that that's 2.136. And so in this case, if I forget to write the little 10 subscript below the log, if you just write log, it's assumed to be log base 10. So if I forget to write that, that's why. So what happens if we've got 10 to the x equals 3.162? Well, in these notes, that's the square root of 10. So x is going to be 1/2, the square root power. But you could also solve that by saying x equals the log base 10 of 3.162. And if you type that into your calculator, you do get 1/2. You can try that. A couple more examples here. What about 10 to the x equals 0.01? So what power do you need to multiply, or how many factors of 10 do you need to get to 0.01, which is 1 over 100? So you need to divide by 10 squared. So that means you divide by 10 twice, and so that's backing up two periods. So dividing by 10 twice. And you can try that, and the log base 10 of 0.01 on your calculator is in fact -2. What about this one? What power of 10 do you need to get 5? Well, you might think it's 1/2, but that's not true. That's the square root of 10. So just be careful that those 1/2s aren't multiplying. It's really a power. So what you've got to do is x equals the log base 10 of 5. And your calculator will spit that out for you. And let me do it quick on my phone here. It's 0.69, 89. And so for some of these problems, we're just going to have to rely on our calculator, but it's a lot simpler and faster than the guess and check method. A couple quick ones we can try here. What do you think 10 to the x equals 1 is? What power do you need to multiply or raise 10 to get 1? Well, 10 to the 0 is 1. And that's true for any base. So the log of 1 is 0 because the base to the 0 power is 1. Last one, we'll do two of them quickly here. X equals the log base 10 of 1.06. That's just telling you what is the exponent you have to raise 10 to get 1.06. And let me do it quickly on my calculator here. 0.0253. Or the last one, this 10 to the x equals 2. What power do you have to raise 10 to get 2? Well, it's going to be less than 1 because 10 to the 1 is 10, which is too big. And so when you type it into your calculator, log base 10 of 2, it comes out to be 0.301. And so we're going to use those values to solve certain problems. And so in the next little clip, I'll show you how you can use these to solve real world exponential